So this is the weight and gravity trilogy foundation exam question. So looking at question 1, we've got a diagram and we can see there's a helicopter and it's being used to rescue a person from the sea. So this person is attached to a cable and this T represents the tension in that cable. It says that the mass of the rescue person is 72 kilograms. Okay, just going to underline 72 and the mass. Use the equation in the box to calculate the weight. So we want to find the weight of the rescue person. So weight is equal to the mass. We know the mass, I'm just going to put it underneath. 72 kilograms times by gravitational field strength. And it says the gravitational field strength is equal to 10 newtons per kilogram. Okay, so show clearly how you can work out your answer. So I'm just going to represent weight using a W, mass using a lowercase m, and then gravitational field strength with a lowercase g. We know the mass, 72 kilograms, you've written it there. And we know the gravitational field strength is 10. And so therefore our weight is going to be equal to 72 times 10, which is 720. And it's a force weight, so therefore units are newtons. Part II, an electric motor is used to lift the person up to the helicopter. The motor lifts the person at a constant speed. Okay, so the clue thing here is the constant speed. Just going to revert here to Newton's first law, which says an object will remain at rest or a constant speed if there is no resultant force acting. So that means that the tension that is being pulled up must be equal to the force going down, which is the weight, because it is not accelerating and it's at a constant speed. So there's no resultant force. So therefore, the answer is also 720 newtons. Part B, to lift the person up to the helicopter, the electric motor transformed 21,600 joules of energy usefully. Use a form of energy from the box to complete the following sentence. So the electric motor transforms electrical energy into kinetic energy. The kinetic energy is then transferred into useful, and because it's being lifted up, it's going to be gravitational potential energy. Oh, sorry guys, I just realised I've written that and you won't be able to see it. So that answer there is gravitational potential energy. Just going to turn over. Question 2. So this question is about forces, and it says A, force is a vector. So a vector is something that has a direction plus a magnitude, which is the same as size. So how big the force is. We can know that because we represent forces by using arrows, okay? The bigger the arrows, the bigger the size. The direction of the arrow shows us which direction the force is acting. So, which is the correct statement about a vector quantity? Has direction only? No, we know it has direction plus magnitude. Has direction and magnitude? Excellent. So this would be the correct answer. A Newton meter measures the weight of an object. So we've got a picture of a Newton meter here. Look at the figure below. What is the weight of the object? So we're looking at that arrow, and where that arrow is halfway between the value 5 newtons and 6 newtons. So it's going to be 5.5 newtons. Question C. An object has a weight of 6.4 newtons. Underline that again. Calculate the mass. They're trying to find the mass this time. Calculate, so we're going to use the calculators. Mass is equal to weight divided by gravitational field strength. And the gravitational field strength this time is 9.8. So, you're going to write out this equation again. just using the letters. M is equal to W divided by G, which is the gravitational field strength. Put it in your calculators. So you're going to have 6.4 divided by 9.8. Put it in the calculator. Then the answer comes out to be 0.65. Okay. Now I've stopped at 6.5 because it's two significant figures, because we've been given two significant figures in the question there, 9.8 and 6.4. So that's enough significant figures for us to write down. D, the mass of the bag of sugar is 1 kilogram. On Earth, the weight of this bag of sugar is 10 newtons per kilogram. So we got the weight is 10 newtons on Earth, but on Mars, the weight of the bag of sugar is 4 newtons. Suggest why the weight of the bag of sugar is different on Earth and on Mars. Okay, for 1 mark. So we want one reason, and that's because Earth has a greater gravitational field strength than on Mars. This means that the gravity is pulling down more on the weight on Earth than it is on Mars, and so therefore, on the mass, and therefore it has a larger weight. Okay, last question, question 3. So question 3, the diagram shows a cable car used to take skiers to the top of the mountain. The total mass of the cable car and skiers is 7,500 kilograms. Calculate the weight of the cable car and skiers. Gravitational field is 10 newtons per kilogram. Weight. Show us clearly how you work out your answer and give the units. Okay, so we've actually seen this equation on the first question. So we know that weight is equal to the mass times the gravitational field strength. Okay, so M for mass, 7,500, times by gravitational field strength, which is 10, times that together, you get 75,000. Now remember, weight is a force, and we measure force in newtons. II, the cable car moves at a constant speed. Okay, just gonna look on the speed. It lifts skiers through a vertical height of 800 meters in 7 minutes. Calculate the work done to lift the cable car and skiers. Okay, so work done, the equation for work done, or we sometimes say work, is equal to force times by distance that force is acting through. And so the question hasn't mentioned anything about force, but we know that weight is a force. Okay, so we're going to have to be using the weight as the force, and that's 75,000 times by distance it moved through. So we know that the lifts and skiers move through a vertical height of 800 meters. Okay, so we times by 800 to give us our work done. So in your calculator, start at 75,000 times by 800 to give us an answer of 60 million. 60 and then 6 zeros. Joules. Last question, part B. The diagram shows a skier who is accelerating down a steep ski slope, okay, accelerating. Draw an arrow on the diagram to show the direction of the resultant force acting on the skier. So, because we know that the ski is accelerating down, it must have a resultant force in the direction down the slope, okay? Because it's accelerating, so we know that the resultant force must be acting down the slope. So we're going to get a ruler. Just going to put it at its centre of mass. The resultant force is going to act in the direction which is accelerating in. How and why does the kinetic energy of the skier change? Okay, so how, we've got to say how and we've got to say why, 2 marks. How it changes as the gravitational potential energy, when he's at a higher point on the mountain, converts into kinetic energy. So gravitational potential is converted into kinetic energy and why? Because the speed of the skier is increasing. And we know that because it says accelerating, which means it's getting faster, and therefore its speed is increasing.